Hi guys, and today we'll actually be putting implicit differentiation to use. Related rates. Whoops, and I just saw a word I just misspelled, so let's change that. Okay, identify what you have and what you need. Hugely important. So when you're identifying variables, you should be able to set them up and just be able to list out what you know and what you need. Okay, it makes your job a lot easier when you're plugging in later. Now what you're going to do is set up and plug in whatever formula you need. You need to take the derivative and then plug in whatever things you need for that, and then solve for what you need, and you should be good. Okay, so let's explain it a little bit more. So let's say we had this. Air is being pumped into a balloon that should be two L's. Jeez Louise. At the rate of 10 cubic centimeters per minute. Okay. Calculate the rate at which the radius of the balloon is increasing when the diameter is 15 centimeters. Okay, so some things we're going to actually going to list out are just the formulas we need. So volume is 4/3 times pi 227 times radius cubed. Okay, so that's a formula we do know. We also do know that the rate of which the air in this balloon is increasing for the volume is dV over dt, which is going to be 10 centimeters per 10 cubic centimeters per minute. That's not going to be actually V, that's going to be dV over dt. Okay, and if you notice, this looks very familiar to implicit differentiation when we had dy over dx. Okay. Alright, we also know that the radius, which is the diameter divided by 2, is going to be 7.5. Okay, so the radius is going to be 7.5. Now, identify what you need, what you have. We have these three things. We have this formula, this piece of information, this piece of information at our disposal, and we need dr over dt. We don't know that. Okay, so this is what we're going to try to find. So, we have step 1 done. Okay, so what we're going to do is set up and go ahead and do it. Okay, now what I'm going to do is differentiate this equation right here. This is going to be the main one I'm going to be working with. Why? Because it's the only equation I have. These are values and I just work with that. Okay, so it's going to be 1 times dV over dt equals 4/3 times pi times 3r squared times dr dt. Now that should be ringing a bell that, oh my goodness, isn't that what I'm looking for? Yes, but unfortunately we don't know r and we don't know dv dt. Oh wait, we do. So that's the beautiful thing about it, is that once you start doing the derivative, you should be able to start plugging things in. Okay, now I just simplify a little bit just to make your job a lot easier. dV over dt equals 4. The 3's cancel out. The 3's simplify to 1. 4 times pi. We got r squared times dr slash dt. Okay, so we have that all set up. Now, what you're going to do is you're going to plug into here the 10, and you're going to plug into here the 7.5. Okay, so now we're dealing with something that looks like this. 10 equals 4 pi times 7.5 squared times dr over dt. Alright, and all we have to do is divide both sides by that, so 10 divided by 4 pi times 7.5 squared and this should all equal dr dt. So that's the rate at which the radius is increasing. So that's kind of cool. Now if it was decreasing, that would be a negative number. If it was increasing, or if it is increasing, which it is, it should be a positive number. Okay, another famous problem is the ladder against the wall that you just come up against a lot. Okay, so going back to our original problem, right, and I did want to cover one thing. This is not the constant speed that it's always going at. This is the constant speed that the balloon is increasing when the diameter is 15 centimeters. If the diameter was 20 centimeters, this speed would actually change, and we would probably change this to 20 to actually find out what it's actually going to be. So it's always changing as you're increasing. It's slowing down as we go up. Okay. Alright, so we have that all set up. So we identify what we have and what we need for the next problem. So drawing a picture is just natural. So we draw our picture, okay, with respect to the ground. So here's the ground. Here's the ladder, and here's the height of how high it is up the wall. Okay, so we know the ladder is actually 45 feet. We know the height it's 12 feet. Okay, but we do not know how far it is from the ground, or do we? We can just go ahead and use Pythagorean theorem. Okay, so ground squared plus 12 squared, which is 144, equals 45 squared, which is, where's my calculator? Which is 2025. Okay, and then once we simplify that, we find the ground length is, let me see, square root of 2025 minus 144. It should be about 43.7 feet. It is from the wall. So this is at that instantaneous moment as the ladder's sliding down. This thing's going down fast. It just wanted to do that. Okay? Alright, now the only formula we actually have is we actually have well, we have the actual height of the ladder. Okay, that's the only actual height that we do know right now. Okay, so if we were to actually write this out in a Pythagorean theorem, a squared plus b squared should equal the 45 squared, which is 2025. Okay, so we do know that. Now, what we're going to do is treat this as our actual formula. What we do need to find is we need to find the rate at which the top is sliding down the wall. So we would call that dh/dt. That's the thing we don't know. Okay, we do know how far it is sliding away on the ground, so dg dt, and we do know that is 5 feet per second, so we do know that that is a 5. Okay, we also know the height is 12 feet, and the ladder length is 45 feet. Okay, so we do know a whole bunch of things. We just don't know how far it's sliding from the top. Okay, so we can pick a variable ahead of time and just work with it as g and t. So I'm going to pick this one. So let's make that g squared plus h squared equals 20, 25. Okay, so we have this all set up. So what we're going to do is differentiate everything. So this should be 2g times dg slash dt plus 2h times dh slash dt equals 0, because when I differentiate it just works out that way. Alright, now if you notice, I need dh dt, that's right here. Okay, so if I just plug in h and g, I should be able to find it by getting it all alone. Oh, and also dg dt. Okay, and if you notice, I just check off them off the list and I just kind of plug in. Okay, so I get 2 times the ground length. Ground length was 43.7. Okay, and this is approximation, so that just happens. Times 5 plus 2 times 12 times dh slash dt equals 0. Okay. Alright, so if we actually do the calculations out, we got 2 times 43.7 times 5. Well, that's pretty simple. I should have seen that coming. That's going to be 437 plus 24 dh slash dt equals 0. Okay, and when I simplify everything down, it should be dh slash dt equals negative 437 divided by 24 and that should be the rate at which the ladder is sliding down the wall at that time moment is negative 18.20, well, 21. Let's make that 21 feet per second. Okay, now some of you guys are probably going, oh, negative velocity, and then you don't think anything about that. But if you think about that, what that's saying is that the negative is telling us that it's going down. So this thing's coming down fast. Okay, it's not losing its weight as fast, but it is coming down pretty darn fast. And that makes sense because gravity's going to pull it way down faster than it's going to pull it across because there's no force there. Okay. Alright, that's pretty much everything about related rates, especially the problems that you're going to be dealing with. Just remember, write down everything you know, differentiate the equation you're given, and then just kind of plug in and just solve. I mean, it's just that easy when you take a look at it, okay? Alright, have a great day. Bye.